Hi, I'm Dave, welcome to the channel. In this quite long video, we're going to build an analog switch for this Carrera digital track. Okay, before we start this video, I thought we should probably have a little chat. Apologies, this video is going to be quite long. There's going to be quite a lot of classroom bits where I'm just talking and there's slides and things, and I'll try my best to punctuate that with, I don't know, we might have a break in the middle or something, because it could get a bit long and heady this, because there's quite a lot to do, and more importantly there's quite a lot to explain, because I'd like you to be able to do it as well. So yeah, brace yourselves, this is going to be quite a long ride, but at the end of it, hopefully, it'll be worth it. And unfortunately, I'm going to have to start by putting out a couple of disclaimers. So here we go. Okay, let's get some housework out of the way to start with. Before we start, here's a disclaimer. You do this at your own risk. If you try and do this and you damage your Carrera Digital CU, that's on you. Don't blame me, I'm not paying for it. And disclaimer number 2, if you have any single lane change curve sections in your track, you will need to remove a jumper wire from those pieces before you plug in this box that I'm going to create. And there are plenty of other videos on YouTube that are available that describe that. Furthermore, sorry, but I'm not going to list all the eBay item numbers for all the bits, because over time they'll change, and I don't want to be doing this endlessly because I've put a video up for the next 10 years. So if you can't find the bits from my description of them in this video, then this project might not be for you. And to the inevitable know-it-all, of course, yes, you can do this with just one relay module. There's a reason why I'm using 2, which I will explain. Be patient. And yes, the power supply is inadequate. If this works, I'll get a better one. Okay, that's that. So, onto the components. Here's what you're going to need. I'm wiring this for UK club circuits, so I'm going to use 5 amp 3-pin round pin plugs and the sockets that go with them. Going to need 2 of those for 2 lanes, and if we look at them, one from the back, you see it's got 3 contacts, a live, an earth and a neutral. We'll get to those later. This is an on-off-on dual pole, no, 4-pole dual throw switch. So if we turn it over, there's 12 connections on the back. It's on in one direction times 4, off in the middle, on in another direction times 4. We'll get to that, I'll explain it more in a minute. This is a DC to DC converter. It will take anything from 8 to 23 volts in, and it will put 5 volts 3 amps out regardless of what you throw at it, because it's a USB transformer. I'm going to cut the USB plug off the end and have 2 wires in, 2 wires out. And this quite scary looking thing, I suppose, is a 4-bank relay module. Now, it's just 4 modules. They're all the same thing, 4 times 4 of them, so kind of ignore 3/4 of this. It's not that complicated. We will get to explaining about this in a bit more detail in a minute. Some other things I've got is some 8-way 5 amp ribbon cable, which is great because 3D printer people mod their kit and you can get that now. Whole load of connectors, a plastic box to put everything in, and the aforementioned inadequate power adapter. But bear with me, it's variable voltage, it'll do for testing. And then when I'm done with it, I'm probably going to use it to power the lights around my track, because it's ideal for that. So with apologies to people who already know this stuff, here's more detail on the 4-pin dual throw on-off-on switch as promised. Here it is from the top and underneath. As you can see, underneath has 12 pins, but you should really look at those as 4 separate sets of 3 pins operated by the toggle switch, which you can see on the top, which has 3 positions. The off position it's in, on upwards and on downwards, but that's on and other on. They're not the same on. If we look at this group of 3 pins, which is one switch in its own right, if we were to switch that toggle switch to the on that's upwards, those 2 connections would join together. In the off position, none of them are joined together, and in the downwards on position, those 2 connections are joined together. And what you're looking at is 4 sets of 3 connections that all work the same way at the same time when you switch that one toggle switch, which is very useful. So let's talk about the 4-channel 5V relay module. It's not as scary as it looks. There is just 4 lots of the same thing. So you can sort of look, there's 4 relays. They've all got 3 connections each on them. We only need to talk about one. Another thing you'll note is the VCC jumper switch. Now, it will sometimes they say VCC and ground, and you can switch them between one and the other. On these boards, if it's on, it's VCC. The other thing to note is that little 6-pin array along the bottom there. The left-hand one says ground, the right-hand one says VCC, which really means negative and positive. And the 4 in between are the triggers that trigger the 4 relays at the top. Don't worry, it's not that complicated. So if we connect a positive and a negative to the VCC positive and the ground negative, if we were to connect to in 1, the first relay would close. In 2, the second relay would close. In 3, the third relay would close. And in 4, of course, the fourth relay would close. And what we're going to do is we want them all to close at once. So we're just going to connect all 5 of those pins together and either power the unit or don't power the unit. And that will switch all 4 relays on and all 4 relays off. So if we look at one of these relays, it's got 3 pins. Now, when there's no power to it, these 2 are joined together. But when you put power to the appropriate input, which in this case is in 3, these 2 are joined together. So it's a kind of flick-flack switch. Either those 2 are joined or those 2 are joined, depending whether there's power on or off. So yeah, this is in the on position, and that's the off position. On position, you get the idea. Right, that's enough classroom time for now. Let's have a little bit of practical bench time. And we need to take the Carrera digital CU apart. There are far too many screws, and there's one underneath that warranty sticker as well, which we'll get to in a minute. But the rest of them are standard crosshead screws. Loads of them. So the one underneath the warranty sticker is actually a Torx head. So if we turn this screwdriver around to be flat blade and we use it, it's a narrow enough flat blade, it will go in the stars of the Torx head. It's not in that tight, you should be able to get it out with a flat blade screwdriver. And then the bottom of the CU comes off. So we take a closer look at this. There's these 2 powers which go all the way through and out to those power outs that are in there. Load of sellotape sticking some wires down. And these are the important ones. You'll see there's 2 sets of copper sliders that go into the tracks for each track. And you'll see all of these wires are daisy chained together because this is a digital system and the signal needs to go to both tracks. Now I'll put these on a bit of paper and you can see, so they come plus and minus out of the CU and to the right and left tracks accordingly, and then they're joined together. Right, now back to the classroom for a little bit, sorry. Okay, brace yourselves for the heady stuff. It's time for the non-schematic-schematic. Here's the components we're going to need. The adjustable power supply. Here's the on-off-on switch shown from underneath. The DC to DC converter that puts out 5 volts. And 2 of the 4-bank relay modules. The Carrera digital CU, of course. And 2 of those round pin 5 amp sockets for the analog side. So let's start with the wiring. I'm going to use blue to be negative and red to be positive on this diagram, because if I try and use black, we've got a black background, it's not going to work. So first 2 wires from the power supply to 2 of the middle pins on the on-off-on switch. And then take the power off those into the DC to DC converter, and then again to the other 2 central contacts on the on-off-on switch. So it's all just kind of joined together really, but the 2 on the left, as you look at them, will be whatever voltage is the variable voltage that you put in, and the 2 on the right will run at 5 volts, which is what we need to trigger those relay modules. So if we look at wiring one of those up to the switch with the 5 pins connected, as we described earlier, just to one side of that 5 volt switch, then that 5 volt output will trigger all of those relays when the switch is switched to power that one. And then if we put in the other wiring as well, you can see that with the on-off-on switch, if it's one way or the other, it will power one or other set of relays and close them all off. And if it's in the middle, it won't do either. Now when you open the back of the Carrera digital CU, you'll find there's lots of wires. If you take them all off, and for the moment just connect each rail to the center contact of one of those banks of 4 relays. One relay, center contact, 1 track per relay. You get me. And then the scary bit is you cut the plug and the wire off the CU transformer power supply and wire it in to that on-off-on switch like this. Yes, you're going to do that. That's going to be a painful thing because you're going to think, but go with me. And the 2 wires that come out of the CU and go to the tracks usually wire into each the equivalent positive and negative, as I've shown there, relays on that relay module. And then to simulate the link line between the 2 sets of tracks, which was evident in the bottom of the CU when we took it apart, join the other 2 relays together as I have shown here. So this is effectively the digital CU still wired directly to the track. As it was before, it just looks a little bit different. And then if we put all the other wires back in for the digital side of this setup, you can see if the on-off-on switch is switched into the up as we look at it in the diagram position, power goes to the CU, it comes out of the CU to the relay module. The relay module is powered, so the relays are closed, and the signal and power goes to the tracks. Okay, let's put the digital side of that away again for a little while. That's been enough classroom time for a minute. Let's have another little break and a chat. Now, when I mentioned that I was going to build this box as part of my Christmas Advent videos, there were a few comments saying, oh no, you're not going to give up the digital, are you, Dave? Well, no, this is a digital channel, and I intend to keep the slot car racing primarily digital. But I am building this box partly as an exercise because I wanted to, and partly because, as I mentioned when I reviewed these 2 cars, I want to try the difference between an analog and a digital setup for the same car on the same track, and compare and contrast for you, but for my own purposes really, because I have no idea if they're exactly the same or totally different. The other thing is, there's a few other reasons why I'd like the ability to run some analog cars. Obviously, that lovely care package I got from Shotgun Dave is all about, building scratch building cars from brass, and usually they would run as analog cars. If I ever built one for a proxy, I'd need to be able to try it and tune it as an analog car on this track at least before I sent it off to anyone. The other thing is, I may at some point get into racing, club racing, and majority of slot car club racing in the UK is analog. There is some digital, but you do really need to be able to prep up a car in analog trim and take it racing. And the other thing is, there are some cars I've got that you just can't chip. I mean, I suppose you could with an awful lot of effort. But to run some of my old Analogue cars on this track would be great, because I've missed running some of them. I mean, for example, okay, so this is a Carrera digital, or could be a Carrera digital car. It's an Analogue car, but we could easily put a Carrera digital chip in it. But maybe I don't necessarily want to. I don't think I'm going to race that one a lot, like I would say this one. But it would be nice to run it around the track in Analogue mode. I've got this car that I've never raced on this track. In fact, I've never driven it anywhere, because I've had it since I had a digital track, and because Team Slot insist on putting this ridge down the side here, and this ridge is exactly where a Carrera digital sensor would go, you pretty much can't chip these cars for the sake of a couple of millimeters and some pedantry on having to build a chassis in a particular way. This car is not chippable. This has to be an Analogue car. So we'll try that at some point. That'll be interesting. I've never raced this before. It's got a few issues, that's for sure, straight out of the box, but we'll try it nonetheless. And I did mention this one before, my Hummer, which is a Ninco car. Nice long can Ninco Raider motor in it. The trouble with this car is it sits a long way off the track, and it has the drop arm pickup. So I think again you're probably going to end up about right on the edge of this lip to try and put a digital sensor in anyway. And with its height off the track, because it does sit fairly high off the track, sensor's probably not really going to work. So this is another one that's probably unchippable, but it's a great car and I'd love to play with it on this track. It's got proper suspension and proper four-wheel drive, suspension front and rear. So again, that is going to be very interesting. And of course, I mean, even by these standards, it's huge. And one more to talk about just at the moment, which is this NSR Renault Clio, which I think was a bit of a limited edition car. I don't really have anything else to race it against, but I'd just be keen to drive it, really. So again, this one, don't think I'm going to bother converting it to digital, because there aren't many other NSR Renault Clios that you'd be able to race it against. So it's sort of a car on its own right. So again, be nice just to be able to stick it on the track and run it analog. So I'm not going analog. I'm going to use analog a little bit. I'm going to use it to add to what I can do with slot cars. But my primary focus will still always be the digital side of things. Don't panic. Okay, so now let's take all the digital side wires off the diagram for a minute and go back to just having the power supply, the switch and the DC to DC voltage, and we'll look at the analog side of the wiring. So as you recall from the previous demonstrations, when the relay bank at the top of the diagram is not under power, the alternate set of connections is joined together. So what we're going to do is take that and take that as the input to go into the track for the analog side. So if you connect the 4 relays in pairs together, as I have shown here, and we can put the track wiring back in at this point to the diagram. We've seen this bit before, so it's just the same wires. And a positive and a negative from the switch, from the higher variable voltage side, round and wired into the live, goes into the live inputs on these 5 amp sockets, and actually don't wire the negative into the negative, wire it into the earth, because what happens next and what happens when you plug the analog controller into the front of the socket makes the circuit work properly. It's slightly counterintuitive wiring, but I've looked it up on the UK Slot Car Club websites, and this is how you wire them. So I'm going to show each of the 4 wires that come out of these 2 sockets to create the 2 lanes in the same colours as the ones that go to the track, and I'll just put them in one at a time so you can see them. Gets a little bit confusing to look at as you're going because they cross over each other a bit, but you should get it. I'll give you a nice freeze frame of it at the end. And so in this configuration, the track will now run analog. The top relay bank is in the off open position, so everything is connected there. Power is going to the lower relay bank, which means those relays are closed, so the power is going all the way through both sets of relay banks and into the track as 2 sets of separate track analog power. So a quick recap, there is the digital side of the wiring. That once again is the analog side of the wiring. And this is the full wiring diagram. Don't worry, I'll show it to you again, don't worry. And the really important thing, and why I used 2 relay banks and wired them together like this rather than just wiring it into 1 relay bank, is that in the off position of that on off on main switch, nothing's connected to the CU at all. So there's no chance, if you flick from one to the other, that a slow lazy relay could accidentally take a while to open or close and inadvertently send charge the wrong way to the CU and blow it up and damage it or anything like that. There should be a clear dead space between on for digital, off, and on for analog, and hopefully no risk of damaging anything. That's the plan, and that's why I used 2 modules, not 1. And maybe it's belt and braces safety, maybe it's overcomplicating it, but it cost me an extra £8 for the other relay module, so I thought it was probably worth it. Okay, that's the end of classroom time, but now we're going to have a bit of bench time, and this is a kind of halfway through work in progress bit of video. So I wasn't going to show you me fiddling around with wires a lot because that gets really boring, but you can see the results. So I've taken a piece of 8-way ribbon cable, ripped it down to 6-way, and soldered it into a little socket and glued that to the base. And then I'm going to wire each of those 6 wires into each of the 6 wires that I need from the CU. And where I've glued the socket into the bottom section, I've notched out the front of the CU, so I've made up a ribbon cable which will connect the CU to my switch box, and that can plug in there, and it will be a nice, fairly elegant, slimline solution without the need to drill any holes in the bottom of my deck or anything to run a wire underneath. And that will connect up to another one that's the other end, thus. And then I've made a start on the box at this point. So obviously all of these wires here will eventually wire up to these 2 relay banks. And I've cut holes and mounted the sockets and the switch and the power input plug. There's the power. And there's the power input. So I've done all of the wiring that's kind of the main side of the circuit. So these are all connected up. The 5-volt USB transformer is putting the power round, and we have power direct to the digital CU. And the analog side is wired into the sockets that the controllers will plug into. And I have wired up the relays to the 5-volt feed. So if I switch it one way, you'll see those relays are activated. And if I switch it the other way, the other relays are activated. So that's my bit of work in progress. And now I'm going to show you where I got to when I'd finished the wiring, but before I'd finished the box. So here we have the ribbon cable connecting the CU to the switch box, as I said I was going to do. And here is inside the switch box with all the relays wired up. I think I did quite a neat job of that. To that socket that is again glued into that box. And if we move up, you can see the wires feed up to the sockets. I mean, it's upside down from the diagram that I showed you, because obviously that's the underneath of the box, but you're getting the idea. So having rigged this up, let's try it. Digital side. And let's go back in time. Analog side. So there we are. That's proof of concept. That works. Welcome back to colour. So if we move over to having it all installed on the track, there's the CU. You'll see on the left hand side is my TrueSpeed digital controller. On the right hand side is my TrueSpeed analog controller. There's the ribbon cable going into the top of the box, which okay. So I cable tied it to the joist at the moment, but it works. There's the power in. Down is for digital. So if we put a digital car on the track, there's the digital controller. That works. Take that off the track. Analog mode. So we'll grab the analog car, put that on the track, pick up the analog controller, and that works as well. And one last close-up look at the install. There's the connector and the low profile ribbon cable going into the top of the box, and the box is very simply two 5-amp sockets, one for each lane for the analog controllers, and one singular switch. So then, let's go racing. We'll do a little bit of digital, then we'll switch it over, a little bit of analog, and then we go back to digital again. Overall, I think that is a roaring success. I think my component cost ended up being around about £95. These prices are obviously as of February 2024. Plus obviously the Carrera CU and the TrueSpeed controllers. But that's it. Job done. As always, thanks for watching one of my videos, especially this one being this long. If you liked it, you will find a button specifically for that. Please subscribe to the channel, it really does help, and if you hit the bell, you'll get a notification the next time I post a video. And of course, check out this slot car channel.